So midpoint is the average between the x coordinates, add the two x coordinates, divide by 2, then the average between the y coordinates, divide by 2. Let's look at an example. So again, you're going to put this example in your journal. Please write with me, we're find midpoint, and then write the two coordinates. So write everything that I have underlined. This is our example 1. Find midpoint between 6, negative 2, and 2, negative 9. Okay, I want us to do a quick graph, just a little sketch, just so we can also see what the idea on two-dimensional is, because we're going to eventually add in the three-dimensional aspect as well. Okay, so let's graph the point 6, 2, just like I said, just sketching 1, 2, 3, 4, 5, 6, approximately over 6 to the right and 2 down. Let's call that point A. And then 2 to the right, negative 9 down. 2, 3, 4, 5, 6, 9. And we'll call that point B. So ultimately, between those 2 points, we are looking for a point that's exactly in the middle there. Okay. That's the idea. And if it's on a graph, you can count the rise over run and split that in half and find out where the middle is. But the formula, if it's not on a graph, is definitely the easiest way to go. So I'm just going to do substitution with you guys into the formula. You have the two x's, 6 plus 2, that you're going to divide by 2 and average. The two y's, Kyle, what are the y's?
Negative 2, negative 9.
The negative 2 and the negative 9, we're going to add together and divide by 2 and average. And you wind up with a coordinate point. Now, don't forget, in the calculator, you would not put 6 plus 2 divided by 2 like this. Why not?
Because it would do the PEMDAS.
Yes, it would only divide by the 2 first, and then it would add it to the 6. So not that way. We want to add the two numbers together, and really, for this part, most of this can be done in your head. 6 plus 2 is
8.
Cut in half.
4.
So our x coordinate for the middle is 4, and then negative 2 and negative 9 is negative 11. Cut in half. 5.5. Okay, so negative 5.5. So you actually have a coordinate point that is midpoint. Yes.
Why is it 2 negative?
Negative 2, negative 9. The y's. Don't look at x, y.
Oh.
Negative
okay.
2, negative 9. The y's are averaging. Okay. So if you look on the picture at 4, negative 5.5 is going to be about in the middle of that segment. Okay, so I think we can find our midpoints this direction. Let's see if we can reverse that thought. Here's example 2. So it's 3, but we're going to make that 2. For your purposes, let's write down end point, negative 2, 8. Midpoint for 0. We are looking for the other endpoint. Find the coordinates of the endpoint of the segment who has one endpoint at negative 2, 8 and a midpoint of 4, 0. Okay, so this endpoint, I'm going to go ahead and put x, y in there. We are looking for the x, y coordinates of the new endpoint. We could probably logically think backwards in our work, but I want us to show algebraically. So tell me, Tyson, the first little part of the formula, what is the x part of the formula for midpoint that you just wrote down?
The x part.
Mm-hmm. Look inside the parentheses on the formula you wrote down and just the first little part, the x1, x2.
Okay.
What is it? What's the formula?
X2 plus x1 divided by 2.
Okay, so that is my x coordinate that would equal that, right? We already have what it equals to, so let's put equals 4. Okay, Skylar, you with me too?
Yes.
So I am taking my two x's, adding them together to divide by 2 and get that value of 4. Well, I actually have one of those x's already. One of those is the negative 2. So let me replace negative 2 plus the I don't know x, and divide by 2 to equal 4. Okay, are y'all with me? So now what am I going to do to solve this tiny little equation to figure out what my missing x is?
Multiply by 2.
The 2 is divided by, multiply it to move it over here. Let's make that 8. And then what?
Add the 2.
Add the 2 on. So the x in my endpoint that I'm missing would be a 10. 10 plus negative 2 is positive 8. Cut in half is 4. Okay, so I found the x coordinate. I'm going to do the same thing for the y. Skylar, can you set up the equation for me to help me figure out these two values to equal that?
8 minus 0,
Not a minus.
or 8 plus 0, over 2.
So, but the only thing is, this is already my midpoint.
Mhm.
So that's what I'm going to get. It's going to be the endpoint.
Okay, so it would just be the algebraic thing. So 8 minus x, or 8 plus x equals 0.
So for now we're doing y.
Y.
So 8
Right,
plus
so
y.
8 plus y over 2 equals 0.
There we go. So we
then
have
multiply
everything.
that times 2, and then it doesn't do anything, so, and then subtract 8, so y equals negative 8.
So we had to say that 8 plus something cut in half gives me 0, and then you had to go through that little solving of equations also. Multiply by 2 to move it over, still 0, subtract the 8, y equals negative 8. So my coordinate point for my other endpoint was 10, negative 8. Okay, so you're just kind of taking that process to find midpoint, but reversing it. All right, everybody good on midpoint? Two-dimensional midpoint. Let's get our two-dimensional distance formula. So before we go to, let me see, I don't think. Oh yeah, I have one-dimensional distance. Okay, so let's kind of recap from the beginning of the year when we were talking about a number line, one-dimensional. If we had the number -2 and we had the number 7 on a number line and wanted to know the distance between the two, remember we subtracted this largest number, subtracted the smallest, minus the negative, we turned it to a plus, and that's 9 spaces, distance of 9, if it's one-dimensional. So the idea is the same for two-dimensional, except for now we have to consider something else. So I want you to first of all write distance formula and formula. So write this and write the formula down. And then we're going to think of that in terms of a coordinate grid instead of a number line. By the way, these formulas are also on the formula chart. They're not something you have to have memorized. They're always available for use on the formula charts.
How do people come up with this stuff? I swear.
Actually, this one I'm going to show you where it comes from.
Oh, wow. History.
Okay, so if we have that written, think about this on a number line. You have 2 points. We want to find the distance between the two. If it's on a grid, you can count up and down spaces to get, your length, but you can't count diagonal spaces because diagonal length is a little bit longer than straight up and down or right to left spaces. But if I look between this point and see what the difference is up to here, the y change, and I look at this distance for the x change, what kind of picture did I just draw?
Surprise
A
everyone.
right angle.
Mm-hmm.
Triangle.
Whoa.
A right triangle. Okay, because that's a right triangle, Pythagorean theorem comes into play.
Oh.
I have a distance, which is a leg squared. I have a distance, which is a leg squared, and it equals the hypotenuse squared, the c squared. So look right here. My change in y, the difference between those distances is this length. My change in x is this length. That's my a squared and my b squared equaling my c squared. But if I unsquare, I would square root it. So this distance formula comes from the Pythagorean theorem. All right. Do y'all have that written so we can go to our example? Okay, so actually I'm gonna show you two different ways to think through your distance formula. One of them based on the Pythagorean theorem, and then one of them by just substituting into the formula. So this is example 3. And just write down distance between P and Q. And there's your coordinate points. So you have your sample problem in your journal. I again want to do a little graph so we can visualize distance for this problem. So I'm going to have you sketch with me. X, Y coordinate. At -1, 4. There's P. 2. -3. Or Q. Y'all sketch with me also, just to have it there for a visual, because I want to show you the right triangle method also. Okay, from P, we're going to drop down a straight distance and then go over to Q to see our right triangle. My first method is going to be by using the formula, the distance formula. The second method I'm going to show you is going to be by using Pythagorean theorem. Okay, so you will get to choose which method you like to do best as far as finding distance goes. Okay, for number 1, we're going to use distance formula, and we're going to substitute in x minus x, y minus y. Make sure you are noticing there's a difference. Midpoint you add because you average. Distance you subtract because you're finding difference in values. So let's fill in. What are my x coordinates, Tyson? -1 and 2. And to be honest, I could go in that order. Actually, I will, just to show that this can do the same thing. You could go -1 minus 2, or you can go 2 minus -1. Either way. Plus, the only thing is now, since Tyson said the -1, 2, and I wrote it down this way, my y's, Holly, which are what and what?
4 minus -3.
Yes, so you're right. I would have to write it down in that same order. I would have to start with -1, so I have to start with 4 minus -3 squared. Okay, my suggestion from right here, because with distance, I'm going to have us leave our answers in square root form. My suggestion is just to go to the calculator and start with the parenthesis. Don't put the square root in there. Start with the parenthesis and enter it all just like you see it.
Oh, wait. Okay, so the distance formula, it's x2 minus x1, right?
Yes, but you can go in either order. So I did that backwards on purpose to show you.
I know, but
You could put 2 minus -1 right here in
okay,
square.
what I'm saying is, why do you have like a double negative on the second one, but not on the first?
4 minus -3 because of the
Wouldn't
negative.
it be -1 minus -2 as well?
It's a +2 though.
Oh, it's a positive 2.
Yeah.
Okay. So that would just be 4 plus 3, right?
Yes. All right, let's put that in your calculator. Find from the parentheses, find the whole thing squared. Or, yeah, I'm going to have you do it in the calculator quick. Nobody got a calculator?
I got it.
Oh, okay.
Holly took my calculator.
I'm always calculated before. You know what?
And we're not doing the square root, so we're going to get a -3 squared plus a 7 squared, and then add them together. Did you get 58?
Nope.
Well, you did it wrong,
Yeah,
then,
wait,
Holly.
Oh, no. Take the square root off. Don't put the square root. Just do the parentheses. Yeah, I just want the number underneath. I think it's this. 58. Okay. So here's the deal, guys. For any of your problems solving for distance, I want a square root answer. Unless it's a perfect square root, then you simplify it. Or if it is a word problem and it asks for it actually in decimal. So Holly, the decimal was like what? 7.6. So on some of the homework, because it's talking about miles, it's going to ask for it rounded to the nearest tenth. But most of the time, your answer you're just going to leave in square root form. Okay, so the square root of 58 is the distance. Now, she got that from just putting all this in the calculator.
With the square root or without?
Without the square root. because see, the square root is still in my answer.
Okay.
All right, let's look at the Pythagorean theorem method. So this is distance formula, this is Pythagorean theorem. I'm still going to use the distance equals square number squared plus number squared, but this is a very visual thing. So I want to look over here and I want to see what is my change in x. So here's my x distance.
8.
My change in x's is between -1 and 2. Think of it on a number line. Here's 2. Here's -1. How many spaces in between?
3.
3 spaces. 2 here, 1 here. So I'm just going to put in a 3 squared because that is how far apart my x's are. Okay? Did y'all see where the 3 came from? Skylar, are you with me? Because this is probably the way you're going to think through. Okay, so change in x's, I have the distance between x's is 3 units, so 3 squared. So technically I'm doing the subtraction kind of in my head, but I'm not ever including any negatives. I'm just thinking in terms of how far apart are they. Now, what is the distance between my y's? How far apart on a number line is +4 from -3?
8.
4 from -3.
Oh, 7.
7. 4 this way, 3 this way. So my distance, my change in spacing is 7. So instead of actually plugging numbers in, I'm visually thinking the difference between these two is 3 spaces. The difference between these two is 7 spaces. Now look, 9 plus 49 is also the square root of 58. So I can get to the answer either way. I can think in terms of Pythagorean theorem, difference a squared, difference b squared, and then do the square root of that sum. Or I can plug in the numbers and use that to find my answer. Either way, midpoint formula, distance formula, that's kind of our goal for today, is just to work with those formulas and solve problems. Okay, any questions on using either set of formula? We'll do our assignment.